So let's say that we have this angle ABC and the ray BD bisects it. Bisecting it means that this and this are the same. So angle ABD is congruent to angle DBC. Another way of looking at that is that the measure of angle ABD equals the measure of angle DBC. This equals that. So to find out the angle measures that we're looking for, we're going to use this equation. So measure of angle ABD equals the measure of angle DBC. Now DBC, we're told, is 34 degrees. So if ABD matches that, ABD has to be 34 degrees. And then to find the measure of angle ABC, we're going to use our angle addition postulate thing that says the little pieces add to the big part. So ABC equals ABD plus DBC. And then ABD was 34, DBC was also 34, so ABC must equal 68. Hopefully not too bad so far. So now what if ABD was x plus 12? So we still follow the same process. The measure of angle ABD equals the measure of angle DBC because they're congruent. And again, DBC is 34 degrees. And now we're told that ABD is x plus 12. So now we want to find x and ABC. So we have x plus 12 equals 34. We just solve for x. X equals 22. Now again, to find ABC, that's going to be adding the two smaller parts together. ABD is x plus 12, and then DBC is 34. But we know that x is actually 22. So 34 plus 34, which is going to get us, again, 68 for ABC. Now our last one's going to be a little bit different. We're not going to get quite the same numbers, and that's okay. This is not drawn to scale. So now we have ABD is 9x, and DBC is 8x plus 3. We're still working off of, since this is a bisector of these angles are congruent, so they are the same measure. So angle ABD is 9x, and angle DBC is 8x plus 3. This is, again, an equation we can solve. Subtract 8x from both sides, we get x equals 3. And now to find our ABC, again, we just add what we have. So ABD was 9x plus DBC was 8x plus 3. But x was 3. So we're going to plug that in. 9 times 3 is 27. 8 times 3 is 24, plus 3. And we finally end up with the measure of angle ABC is 54. Again, slightly different numbers, but that's fine.